Okay, let's do this. It's going to be a medium number of people aware of a secret. On day one, one person discovers a secret. You're given an integer delay, which means that each person will share the secret with a new person every day. Starting from delay days after discovering the secret, you're also given an integer forget, which means that each person will forget the secret. Forget days after discovering it. A person cannot share the secret on the same day they forgot it, or any day afterwards. Given the integer n, return the number of people who know the secret at the end of n days. Since the answer may be very large, return modulo 10 to the 9th plus 7. Okay. So if n is 6, so that means after 6 days, where it takes 2 days before will share the secret. So it takes 2 days before they share the secret and 4 days 5. So I think day 1 starts with 1. Okay, yeah. And then day 2 is still 1, I think, right? Yeah, because it's still within delay. Day 3 is when they start sharing it. So 1 plus the delay is 3. And that one person shares that one secret. And then day 4, that's still going to be another 1. So it's now 3 people. Day 5, the 2 people from day 3 will share the secret. So it's another 3 people. No? Oh. Is it forget before? Yeah, so between day 4 and day 5, the first person forgot it, so it went down to 2. B shares a secret with another person. So it got down to 2. So between day 4 and day 5, it went down to 2 because A forgot it, and A also was part of this day 3. So there's only one person that still remembers the secret, and that one person shares it. So it's now -1 plus 1, so it's now 3 still. And then day 5, how many people has forgotten it? So day 2 person has already forgotten it. Day B shares the secret with E. C shares the secret with F. So 4, B, and C are still remaining. Oh, okay. Wonder if this is, okay, it looks like I can probably just do, let me think. Looks like I could probably do, do I need to keep track of each one individually? Number of people that know the secret. Number of people that know the secret. So what I'm thinking is for each person, they're going to affect the increasing like I'm thinking if you consider first order effects or the number, the derivative, and the acceleration, the second derivative, or the distance, the velocity and acceleration, first order, second order, third order, or zero order, first order, second order. For any particular person, they affect, if you think about the number of people as being the distance, and increasing that being the velocity, that person can change the velocity at certain times. Basically, they'll increase the velocity by 1, increase the people that know the secret by 1, starting at the day when the day plus the current day plus delay, or the starting day where they learn the secret plus delay. They'll increase the number of people that know the secret by 1, the velocity, and then they'll decrease it by 1 when they'll decrease that velocity by 1 when they forget on the forget day, and also they'll decrease the count of the people that know it by 1 on that forget day. I think maybe that might work. So for each person, or if I think about having a velocity counter, a velocity array that keeps track of how much things were increasing and decreasing, and then a raw count offset. So the expiration of the person who remembers the secret. Okay, so let me try it. See if this works. Count adjust is going to be 0 times the number times n, maybe n plus delay. I think I need to know more than that, or I think I'll ever index past that, and then change adjustment is also going to be 0 times n plus delay, maybe. I should probably simulate what I'm thinking with the actual data first, or with something first, but this seems simple enough that I think I need to work with that. Alright, so let's start with, there's going to be a raw count. That's the same as the answer count. And then for each day in the range of n, so I think maybe initially on that day, I think I need to start by adjusting it. So I'll say the count minus count adjust for that day. Count minus equals however much you need to adjust for that day, but people who've forgotten. And then I also probably need a delta of this is a velocity change in the number, or the it's a different term for velocity. It's the derivative. Okay, I'll call it the increase. going to increase by 0 normally. But I'll say increase changes by whatever the change adjustment is for that day. And then the count is going to change by whatever the increase is. Okay, so then this is the new count. So is this right? So like moving, okay, let's just work a little more. I think what would happen here would be this count. So the increase in the number of people for this day should affect count adjust and change adjust for some number of days after this. So the increase, this is the new people for the day. Maybe I should be that right. How does the first person get it then? Okay, I think I probably actually should start with count 0 then. And it should be increase. So the increase should be starting at 1 maybe? No. The change adjust should start at 1. Change adjust day 0 is 1. So on the first day, I'm going to say there's going to be 1 adjustment in the velocity. So there's going to be 1 increase on that day. The count becomes 1. And then based on this increase, these people will forget change adjust, no, count adjust minus, or count adjust should be on the day plus the forget is going to equal the increase. Is it equal or plus? I think it equals, because they're all, each person forgets in, or each day has a certain offset, and it's not like day 3 and day 4, the people there that spawn on those days are going to forget on the same day. So this is just an equal rather than a plus equals. And then change adjust on day plus delay is going to equal the increase. So if you have a person that is on day 1, that person is going to count adjust, which is to remove themselves when they forget, which is on day 1 plus 4, which is day 5. And then they also increase the change adjust on day 3. Okay, that's right. Okay. So let's see how far away this is. So actually I need to do the module do. I think. Well, I can worry about the module in a bit. So this goes out of bounds. n. Okay, maybe delay plus 1. Do 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 do. Day plus forget. Really? Mouse is going out of bounds. Oh, forget is possibly longer than the delay. Is the forget always longer than the delay? Yeah, okay, forget. Yeah, I think it should have been just, it shouldn't need a plus 1, I don't think. Could be wrong. Okay. Alright, pretty darn off. Pretty darn off. Alright, let me go ahead and print out the count adjust and the change adjust. Ooh. Oh yeah. Count adjust decreases the count for that day on the day that they forget, and also they also need to change the change adjust that day. Okay, if this is actually gonna affect it. So this is plus equals, and this is minus equals increase. Because on the day they forget, they also removed that velocity. Still very wrong. So day 0. So this shouldn't remove anything. The increase should be 1 on day 0. And then the count adjust on the day plus forget. So this person forgets it on day 5. So 0, 0 plus 4. So 0 indexing, this is day 4. Okay, so they forget on that day. Oh, whoops. Well, why is this down to 10? Oops. The increase, yeah, this shouldn't have started at 10. Okay, maybe that might be an issue. Okay, a lot closer. Alright, so on day 0, the count is going to be 0 here. It changes by 1, so day 0 increases by 1, or the increase overall is 1. So the current increase is 1. Actually, that's not correct, right? The current increase should be still 0 on that day. The current increase should be 0 on that day. Alright, so it's supposed to be the count should have a sequence that is 1, 1, 2, 3, 3, 5. So that's the goal target. 1, 1, 2, 3, 3, 5. So person increase should be just 0. So maybe I just need to simulate the first person individually rather than choose the increase to simulate the first person. Let's use this increase. Should this thing work for the first person? I have a new person spawn on this day. So first person, actually, so if I have one new person here, that person increases the velocity over here. So the velocity doesn't change until later on. Velocity changes here. Suppose the first person is named. That first person, if there is, let's say, delay is 2 and forget is 400, then every day between 2 and 400 should have one more person that learns the secret. The velocity should be when that person maybe I need to increase when that first person spawns. So I need to change the count by 1 on that first day, or change Do I need to set it up so that change it just to 0 on the first day and then change it just to 1, -1 on the second day? Seems a little hacky. Let's see how this goes. Even if it goes well, I need to spend more time thinking about it in terms of why it works like this. Oh, I forgot the modular thing. Where is the modular needed? I think the modular is needed here maybe. Plus equals This number return it modulo. Whatever. What if I just did this? You can get too large in the actual runtime. Okay, seems fine in the actual runtime. Is this still printing out? Okay, I need a... What is going on here? Why is this set up this way? So, what is the right way to set up so that they have one person on the first day? If I do, what if I just did count of 1 to start rather than doing this? I think count of 1 to start just means that it never goes away and never really does anything. So the count changes based on the count just for the day. And then there's some increasing velocity for how many people are there on this day. So this is really where the new people come in. This is intended for just people forgetting. This is an array of people who forget on a certain day. Actually, maybe I should just call this forget. Getting is count is going to be subtracted by how many people are forgetting on that day, and this is just forgetting. Okay, so my starting value shouldn't be really affecting that, I don't think. And this change adjusts the, I guess I can call this array of sharing of count of shares on a certain day. Okay. In which case it does make sense that on day 0 there's going to be one person that is shared. Well, it's kind of yeah, it makes sense that the starting points are going to be 1 and -1. So basically there's some sharing that just magically spawns that first person, and then that person doesn't, or whatever causes that first person to be to gain that secret no longer applies in the second day. So the shares based on that initial thing is only on that first day. So there's no one sharing the secret necessarily. This is count of shares. This count of this array of change to count shares. Change the count of shares on this one day. So there's one new share on the first day, and then that change is removed on the second day. So this is, yeah. So here, this is maybe the the number of shares and the number of people who know the secret. Who know the secret, number who will share the secret. So the count of people who know the secret will be subtracted by the number who forget in that day, and the shares will change by the number who are sharing in that day. Yeah, the number of shares increased by the number who change that number of shares. And then forgetting, the number who will forget will be all the shares, all the current shares. All the current shares will forget. Right? This plus equals. I'm actually not sure why this is plus equals rather than just equals. Okay, anyways, I need rename these things. Okay, forgetting is the number of shares. Some number of days, forget days from now. And then the change adjusts. So sharing will okay. So on the first day, there's 0 for the count. Get 1 share. That share will forget. That share will forget. This works, I think. Then don't check. Not sure. This changed 1 millisecond, but whatever. Oh, just random. So I'm wondering why this thing is plus equals right now. Why isn't it just equals? So count is removed by the number who forget. The shares is a running is some amount of people who are sharing it, and forgetting on the day on this day plus forget number of days is going to be the number of shares. Why is that? Okay, so yeah, so the shares not only represent the increase in the number of people who would know, so the number of shares affect the number of new people that know it. Okay. Number of shares as each sharer shares, this translates into the new people on that day. Okay, so the count of new sharers, the count of the sharers on the day matches the count of the new people that would learn the secret on that day. And for each person that learns that secret on that day, they'll forget on that day plus forget day, forget count, forget offset. And then for each new person, they'll also increase the number who share on the day plus delay offset. And for each share, they'll affect the number who would stop sharing on the day plus forget offset. Yeah, okay. Okay, so for this problem, the above solution models simulates the situation using a few it's a flow. Let's see, a few counters. What was the term that we put? Flow versus non-flow values economics. Yeah, stock versus flow. Okay. Let's simulate using a few stock and flow variables / arrays. Variables. Stock is the stock variables are count and count, which is the number who know secret, and shares, number who will share secret for a given day. Flow variables are forgetting and sharing arrays, which affect those stock variables on the indexed days in the future. So initially stock variables are 0, no one knows the secret, no one shares the secret. We're getting, or initially, flow variables are all 0, except sharing on day 0 is 1, and sharing on day 1 is -1, to simulate that the first day will change the share count by 1 and remove that share, that special share on day 1. I guess I should call this day 0. Actually day 1, day 2. Okay. And simulating the days using a for loop to iterate over a day index. The count will decrease by the number who forget on that day. The share flow value changes by the share change for that day array. Based on sharing that day. Whatever the new share flow stock value is equals the number of new people who learn the secret on that day. For example, if day 3 sharing count is the share count, the share stock is 5, that means the 5 shares will cause 5 more people to learn the secret. Thus, therefore the share stock should affect the forgetting value at day plus forget, the sharing value at day plus delay, and the sharing value at this is going to be an increase positively, and the sharing value at day plus forget, this is going to be a decrease negatively. Lastly, the count stock, count of the number of shares, count the number of people who know the secret, should increase by the number who learn the secret on that day. So that's all this stuff. These new folks, these new people will forget, these new people will share, and these new people will stop sharing. New folks start sharing after delay days. New folks will stop sharing after forget days. Count increases by number of folks. Okay, so overall, this problem boils down to correct usage of kind of stock/flow simulation of the situation. Just being very precise about how you want to handle that simulation, because I don't think you can get away with having just one array that tries to do both the mapping of forget and sharing. or just one variable that handles both the numbers of people who know the secret versus the number of people who share the secret on a given day. Alright, anyways, time complexity is going to be O of n, where n is the number of days. Also note that just to avoid a bunch of checks for out of bounds, you can just create a slightly longer array to have kind of dummy values, dummy low values later on in the things, so that you don't have to do like day forget is less than equal to n or something like that. If day plus forget is less than equal to n. Since each day is iterated through in the for loop to simulate what occurs to the counts on those days. And then space complexity, this is going to be O of n for the arrays to track the future flows of forgetting and sharing in the model. Alright, cool beans.